Good morning, Doctor. Today I would like to present our transform circuit assignment, and we are from Group 1. And this is my group member, which is Jack Kiket AE230058, Jopali AE230073, Betty Seng AE230053, and me, Ting Sing E AE230061.
For this circuit and waveform, we will derive a Fourier series based on the output we obtain. From the waveform, the outputs value we obtain are v of t equal to 20 when t is between 0 to 1 and v of t equal to negative 20 when t is between 1 to 2. The period of the function t is equal to 2 and omega naught is equal to pi. A naught value or the DC component value is calculated with the formula a naught equal to 1 over t. Multiply the integral from 0 to t for the function v of t dt, and the value we get is a naught equal to 0. Next, the formula 2 over t multiply the integral from 0 to t for the function v of t cos n omega naught t dt is used to find the an value. The value that we get for an is 0 as it is an odd periodic function. To find bn coefficient, we use the formula 2 over t multiply the integral from 0 to 2 for the function v of t sin n omega naught t dt. For bn, under n equal to odd condition, bn is equal to 20 over n pi, and under n equal to even condition, bn equal to 0. Then, we use the trigonometric Fourier series to find the value of the function v of t. By substituting the value of a0, an, and bn into the equation, the function v of t is 80 over pi sine pi t plus 80 over 3 pi sine 3 pi t plus 80 over 5 pi sine 5 t, and so on, both under n equal to odd harmonics condition. To sum up, v of t is equal to 80 over pi, multiply the summation from k equals 1 to infinity of 1 over n sine n pi t, where n is equal to 2k minus 1. In order to find the Vs value, we need to first find the an value and the phase angle value. Then, by altering the Vs of t function into the amplitude phase form, the Vs value can be obtained by substituting the corresponding odd harmonics value.
Next is a part to find the current on each branch. For finding each current, we need to find the total impedance in the circuit first. So in this circuit, the total impedance is negative 18 n square pi square plus j37 n pi plus 24 over negative 2 n square pi square plus j5 n pi plus 4. After finding the total impedance, we use Ohm's law, which is V equal to IR, to find the current flow in the circuit. Then we substitute the total impedance and voltage into the equation. Then we use simple mathematical solution to find the answer of the current. For DC component, we know that the n term value is 0 and omega value also 0. So substitute this value in the V equal to IR to find the DC component current, which is equal to 0. To find the current I2, we use the current divider rule, which is ZB over ZBC times current I1. Then we use a simple mathematical solution to solve the current I2. Then for the DC component part, we know that n equal to 0, omega equal to 0. So we substitute the 0 into the current divider rule. So we get the I2 for the DC part is 0 ampere. To find the current I3, we use the same method to find the I2. So for I3, the current divider rule formula is ZC over ZBC times current I1. Then also use a simple mathematical method to solve the current I3. Then for DC part, we know that the omega is equal to 0. So substitute the 0 into the current divider rule. So the I3 is equal to 0 ampere. To find the voltage of n equal to 1, the formula that we use is V0 equal to I3 times Z3. At n equal to 1, the value of voltage is 20.7911, angle of negative 52.78. At n equal to 3, the value of voltage is 18.0854, angle of negative 17.85 degree. And At n equal to 5, the value of voltage is 17.8850 angle of negative 10.57 angle. After that, we sum all these values to find the Vs. For DC component, we know that there is not any not, so n equal to 0, then sub the 0 in the formula and the voltage V naught for DC is equal to 0 watt.
This is our calculation to find the power at resistor 5 ohm. We will use the value of I1 that we get from the calculation above. Then we sub the value n is equal to 1, 3 and 5 that we can get the voltage of each in. Then we sub the values into the formula to find the power. Then we can get the final value of the power, which is 24.62 watt.
In simulation part, our group used PSPy to complete our project, and this is our group circuit at PSPy. Then we can see the I circle part and V circle is about the ammeter and voltmeter to test the value voltage and current flow. Then we run the circuit, and this is the result and the value of the V source, I1, I2, I3 and V naught.
And this is the comparison using the manual calculation and simulation. For manual calculation, it is more simple, but for the simulation, it is more complex. But when using the simulation, we will get a more accurate data than using the manual calculation. Meanwhile, the manual calculation is more time consuming to get the result, while the simulation is less time consuming to get the result. And for the manual calculation, it will cause the errors from human mistake or rounding issues, while for the simulation, it will cause the errors from incorrect input data.
Thank you very much.